Hello from Ursuline College. Ursuline is a small, women-focused liberal arts school in Pepper Pike, which is a suburb of Cleveland, Ohio. Ursuline is a recognized leader in healthcare-related fields. My name is Lynn Ulatowski, and my colleague Lita teach cellular and molecular biology, lecture, and lab, respectively. We, of course, want to align and supplement the lectures with lab experiences. Particularly this semester, we worked closely to engage the students in some extended independent research that they are sharing with you today. In lab, Dr. Yu spent the earlier part of the semester introducing and reinforcing technical skills and adding scientific experiments supporting the lecture content of the course. This approach culminated in students taking one of the weekly lab experiments and essentially making it their own. In groups of 2 to 3, the students choose an experimental model they learned throughout the semester and extended the experiment by changing and investigating 2 parameters. The students were then tasked with writing a protocol, ensuring that they had all the materials and equipment that they needed, followed by several weeks of data collection. The students were responsible for taking their new ideas from concept to presenting a poster at the Ursuline College Annual Research Symposium. This was a great feat for a one-semester class. Today we present to you Lailah Pugh, a junior biology major, Sophia Radosevic, a junior pre-vet biology major, and Christopher Forster, a junior pre-med biology major. Sophia, CJ, and Lailah compared anticoagulation effectiveness of NSAIDs to aspirin and acetaminophen.
Hello. Aspirin is known to be a blood thinner. This is in part because it belongs to a class of drugs known as NSAIDs, which are used as anti-inflammatory and as pain relief. Other known NSAIDs sold over the counter include naproxen and ibuprofen. We wanted to test the ability of these anticoagulants when compared to aspirin. Acetaminophen was also chosen as a non-NSAID pain reliever. We chose 3 species of blood, cow, sheep, and horse, to test the behavior of these drugs. Our first hypothesis was that ibuprofen would act the most similarly to aspirin because it is also an NSAID with the most similar chemical structure. It has only 1 ring, whereas naproxen has 2 and should theoretically be less reactive. Acetaminophen should have little to no reaction against clotting. Our second hypothesis was that the NSAIDs would be most efficient in sheep's blood because they are the most evolutionarily close to humans.
Blood types were treated with quick clot powder and either the NSAID drug naproxen or ibuprofen or the non-NSAID acetaminophen. Trials were repeated 3 times on each blood type, and the clot weight for each treatment was recorded after 5 minutes. A lower clot weight indicates high anticoagulation properties, while a higher clot weight indicates low anticoagulation properties. In our results, aspirin had the lowest clot weight, which is expected as it is a popular blood thinner. However, naproxen and acetaminophen were also effective blood thinners. Acetaminophen being an effective blood thinner is unexpected, due to it not being an NSAID. Naproxen's efficiency as a blood thinner was expected, due to it belonging to the same class of drugs as aspirin. Ibuprofen also did not behave as expected. It had a high clot weight and was not an efficient blood thinner. Once again, unexpected, as ibuprofen is an NSAID like aspirin and naproxen. None of the drug treatments had significant clot prevention in sheep blood, but all NSAIDs were efficient blood thinners in horse blood. This is unexpected, as sheep are closer in relation to humans than horses.
With our results, we concluded that our original hypotheses were refuted. Ibuprofen is not comparable to aspirin, while acetaminophen is, and sheep's blood does not react similarly to humans. Cow and horse blood reacted significantly, which also challenged our expectations prior to the experiment. with every drug except for acetaminophen being effective on horse blood. Some limitations encountered include time constraints that made it difficult to collect ample data, and certain methods employed did not react in the intended manner. Our original experimental design included using all human blood types and Rh factors, but was changed to animal types due to cost and safety concerns. Future changes to this experiment would be using thrombin instead of quick clot to simulate more natural clotting. Drug treatment solutions should also be created using something that is more similar to the body's natural environment to ensure complete homogeny of the mixtures. Additionally, human blood would be preferred if possible. Based on this experiment, we learned that the efficacy of naproxen and acetaminophen are comparable to aspirin, and that ibuprofen is not an effective anticoagulant drug. We also learned that despite sheep being closer to humans phylogenetically, their blood does not react in the ways that were hypothesized. Thank you for listening.